Happy Friday! Welcome back. I have had nothing but bad luck the past few days. Even with this, I just started the opening and the phone rings. Solicitor. Bought a new shaver. It's busy tearing my face apart. I gotta return that. And did a brake job yesterday. And of course, all of a sudden I'm looking at my arm going, there's blood pouring down. When did that happen? And of course, inevitably, when a bolt doesn't let go, you're going to slip. Ratchet slip. I'm wearing those white latex examination gloves to keep the grease off my hands. Slipped, and I don't know what I hit with the tip of my finger, but boy, it hurt. You run around cussing for a while, and then, okay, it's calmed down, and it looked funny inside the glove. I take the glove off, my whole hand's full of blood. Now, how you can put a hole in the tip of your finger and not the glove, I have no clue. But enough of my ranting and raving. What have we got here? On the vice jaws, there's two things I keep forgetting to mention. One, not intentionally, but I made the jaws bigger, intending on cutting them to the same size, but wound up leaving them alone. They're 1 inch tall, which now I had bought the whole, long time ago, a little machine shop parallel set. Is it open? No. And I could only use the first 3 sets because of the height of the other jaws. Now I can use 4 sets. So it gives me more flexibility, which is nice, and they're wider by a 1/4 inch on each side. The other thing that I realized as I was saying, I took it apart because it chips in the lead screw on it. Hey dummy, you put tape on the lathe on the back cover to keep the chips from going into the motor. Put tape on the hole, and don't let. So I've got tape on it now, so the chips can't get in there on the lead screw. So you guys might want to consider doing that. What else have I got? Yeah, I was just thinking the other day, it's like, what have I actually done in this shop? Projects versus tools. And I started kind of counting things up, and I've actually done 15 projects. That's it. Like the fire eater, the flame eater engine, and so on. And then I counted how many tools, and there's over 130 tools that I've made. So most of my time is making tools. Big deal, I guess. The cutter that I mentioned will be coming up soon, but this video is about clamps. I had an idea, well, one of them is an idea, which is a clamp made out of a pipe, and I'll show that. And the other one I saw, because thinking about these brass holding things, anytime you have a straight surface that's going to clamp something, and if it's new stock, it's going to have an irregular surface and it's going to pivot. So I'm making clamps that clamp in and come down at the same time, and I'm doing it on the rotary table because I want low profile. So I didn't do a lot of taping on both of these clamps, so what you're going to see is kind of jumping around. And the other thing on the clamps that come down, it seems like every time I started to tape, I started complaining about how tedious it is, so I apologize for repeating it some 50 times probably. So I hope you get something out of the video. Zoom in a little this way so you guys can see this thing. This was just, I picked up a 4-foot section of this at Industrial Metal Supply. Oh, sharp guy. It was like $1 for it because I'm going to make clamps on it. I machined it. Like, look at this. I don't know what this is. I went on their website and it just says it's galvanized steel, but this machine's more like stainless steel. It comes off in long strings, and it's pretty tough too. But so here's a piece that I'm going to use here to cut the groove in it. I'm going to cut it and clean up the ends for a clamp. But boy, I'd sure love to know what steel this is, because I'd love to buy a ton of it. There, turn some light on here in a second. Dude. It's tough to figure out what size to use. Usually I do an 8mm screw, which happens to be the exact same size as the 3/16 end mill, but I figure I can just come out both ways a little bit and give it a little bit more relief. Clamped it in there, kind of think I know, made a mark here, I'm going to cut it off there, and the other side, and so let's see how it works. But so, I can come down a bunch here. Figure if I'm going to screw up an end mill, let it be a grizzly one. Probably need to be a little bit off center. Someday. There it is. This stuff machine's really nice, and I'm just going to use pure soluble oil here. Seems to work the best. Some place to put it. Alright. Then a few thousandths and back and forth. Cutting it nicely. So, just take a little bit to do this, that's all. Probably should go a little bit more RPM than that. Yeah, it might be too much. Dead slower. Well, bring it back when I'm kind of there. That's an absolute mess. Lower the camera a little bit there. Everything's stuck to the tape. There's grease all over it. Wow. Shoot. Well, that's just a lot. Yeah, once I got through, I just went straight down and then walked to both sides, and it looks like the end mill survived this. Good. No marks in the vise. Yuck. Yeah. Looks like it's a pretty good mill job, I can't tell. Yeah, it is. Nah, it's okay, I think. Can't really tell. So I may have to go in with something else. Yeah. No, it's not that hot, but whatever. So I guess I just do the other one and then cut it in half. Well, I'm going to bail on this idea because the end mill was just butchering it up. There's nothing, but it's more like it just pushed the metal out of the way, mushroomed it out, than cut it. I tried, that was the Grizzly 3/16, and then I went in there with a little teeny 2-flute carbide that I had. It's just, nah, this doesn't work nicely. I don't know why. The ball driver was doing fairly nice here, but not on the sides. So this stuff turns nicely, bores nicely, but I don't know what you do to mill it. So the idea was, yeah, you cut this here, and then you cut it somewheres here, and then it becomes a clamp. The screw comes up through there, and you can, do I have any? I don't really have anything, but, so this would rest on the surface, and this would rest on your part over here. So being on the surface, your screw can be here, and then you can pivot it down pretty far, So I thought it would be a great idea, especially, well, that's why I bought this piece of pipe. So I don't know what I'm going to do with this. I got 4 foot of pipe that it's just sitting over there underneath the other bench. Figured I'll just try this one last time before giving up. And what a mess. So this, there was a Craigslist machinist downsizing, And so he gave this to me because it's actually a double. That the end mill's here and it's on the other end, but he snapped off the other end. So I had this in a junk drawer because I didn't really like it being broken like that. But I pulled it out because, you know, I've got an end mill from somebody who knows what they're doing, I guess. Ran it down in there, and you can see it's still a mess. I figured I'd just mill this thing and then I'd turn it in a lathe to clean up all the burrs. But the side walls and stuff in here it's just a mess. So I don't know what I'm doing wrong here, why I can't machine this, but in any case, like I said before, the Industrial Metal Supply website just says steel, zinc, or galvanized steel. I did take a magnet to this, and it's not magnetic. And like I said, this stuff machines like stainless, so I have a feeling this is stainless. And I'm not sure what you're supposed to use. I've seen YouTube videos of people machining stainless. Actually, not machining, I've seen the aftermath, and it looks fine, so I may wind up calling my contact at Travers Tool and ask their advice, the engineers or whatever. What do you use on this stuff, whatever it is? So, well, for now, I'm hanging it though. I just love power feed sometimes. Set it and walk away. Just a little bit more to go, and then I can cut it up and start making the clamps out of it. These are tedious to make, let me tell you. So I did the long channel and cut it. I actually have enough. Just happens to be enough there. I can make another one of these guys for whatever it's worth. And faced them off on the ends, cut them all to the same length. So now what do I gotta do? I guess I gotta go in and mill the notch out on all of them, and then I'll show you guys the angle. It's not that difficult. How did I put it in the mill? It goes in this way on an angle block. No, wait a minute, I used a 10-degree angle block, so it's going to go in the mill, not that way. Oh, the angle block goes in there the other way. So it's put in there like that, and then the mill just eyeball it to come down to this corner and cut it. Pretty easy. Drill and tap the whole thing out. But these slide in nicely, and I'll have to chamfer the edges on everybody. Still want to do a relief on this for whatever it's worth. This is a painful part to make. I wish there was some easier way to do it, but so that guy works. Then I'll have 4 clamps. Just thought I'd show a little bit of machining of these things. This is the clamp here. Pretty nice finish, huh? The Travers tool, this is the 5/8 cutter. Almost there. These are the most painful, tedious things to make. Wow, I just have these guys to do, and this is going to be tough. Now, well, I had some spare left over, so I got to clean that up, drill and tap that out, have another one for whatever it's worth. These are not fun because you always get chatter trying to clean it up. That didn't come out too good, but so almost there. 3 more to go, and then they've got clamps there, and I can try them out. Second trip to Marshall's. Hopefully I got it right. $9. A lot of stuff. $2 of it's this drill bit. I don't know how much the spring was. How much is this spring anyway? Spring. Well, it's $2. Wow. So that's basically $5 for that pile. Put this in here. And I'll just put that to the side. So, hopefully. Alright, take this one. Is this the longest, guys? Yeah. Nothing's longer than that. Figured stainless steel. What the heck? Goes in there. Yay. Because that is not going to move. Which one of these? This one? Yeah. Right. Oh. Dirt's in there. Getting tight. Yeah, dirt or chips or something. Or I didn't tap. No, I tapped them all the way. Yeah, cleared up now. Alright, and I doubt it whether it's their stuff. So that's going to go in there. And it should clamp down. There it goes. Now that is not moving anyplace. Oops. Get rid of all this stuff. That, and that. So, yeah, I guess I should probably just finish this one. And I did get, I forgot which size. I got an assortment here. It looks like they're all the same. So, washer goes on there. This goes on here. Probably should have gotten a shorter set too. But, yeah, that should give me lots of room. Yeah, maybe next time I go I'll get a few millimeters shorter. All of those. Figured I'd just get 10. 10 of everything, why not? And I also picked up some smaller, I think a couple of smaller size. That size, and that big ones. So this should be cool. Let me finish putting them all together. Now it's a test to see if it will hold something. So this is raw stock, irregular surface. So it can grab it like I did in the vise. Alright, so let's get over there. Yeah, not too hard moving it. So I need to lock that down, lift it up, push it together. That's a little too high. Now clamp it down. Perfect. Yep. Part just moves in there. So if I say I want there, hold it, tighten this guy down a little bit. That's tight. And that's tight. I don't know how tight you go, but it's jamming down in there. And that part is not going anywhere, and it is seated all the way down. Do I have a feeler gauge here? How far down does this go? There are 1,000th in here. Thick. Where's thin? There's 4,000ths. 3 thousandths. 1.5. 1.5 thousandths, and they're all oily. So this should not. Yep, does not. No, that part is down solid. Beautiful. So it works. A lot of time to make this sucker, but it works. So, and it's nice. Oof, not that low a profile, because that is going to hit those screws. So I probably need to countersink, take an end mill in there so I can go down at least to this height. I can't machine everything down. So it does have a height problem, in which case I'll have to shorten these because they go all the way down now without hitting the bottom. I don't know how close they are. Let's see. Oh, they just started poking out. So yeah, if I countersunk it, I'd have to definitely get shorter screws, but success finally. Sitting here playing with it, centered up the camera a little more. This is pretty much a kick. Well, one of the things I was thinking about is I've got a lot that I could have cut off here, and then I could have taken that down further and had this the same width as this, but then that's all I have for surface area. So if you're going to take extremely light cuts on something, you can make them a lot smaller, lower profile. Since they're slotted, I think I'm just going to try to go back to Marshall's for a third time and just get some of the lowest profile button head, whatever there is there, to get it down lower. But this is like a 4-jaw independent chuck, because I'm realizing if I center the mill absolutely perfect to this table, and let me get the flywheel, for instance, if I want to recenter this guy, I can put the gauge pin back in the chuck. Oh, he's tightened down. Back in a collet, and I can put him here. And as I tighten these guys, I can move it, I can shift it independently, quite a few thousandths actually. That's a lot of angle here that I can move it on. That's probably 20-30 thousandths, but you can easily recenter up something by just messing with these screws and put it exactly where you want. Because I think I've discovered that this hole is off center. Something's off center here, so it's not in balance if I wanted to make something high speed out of it. So I'd like to be able to recenter it and then recut all this stuff so that it's nice and balanced. But that's a kick. So these are pretty useful. I think the project was well worth the time and effort.